So welcome back to the lecture series on design and of RCC structures and steel structures. Code 17 CV72. We are in module 1, thus RCC structures designs. Lecture number 7th we are on. In yesterday's class we have studied about a new chapter, that is retaining wall. We have learned the definition of retaining wall, types of retaining wall, then how they have been after giving the dimensions, stability checking of retaining wall is done. So you can see the retaining wall shown in the diagram here. This is, we call it as retaining wall. So something which is upholded in the backside of the wall is called as retaining walls. Mainly you can see they are used in across the roads where the elevations is difference between the two ground level is more, depending upon the site conditions, depending upon the depth, depending upon the requirement. They have been specified, classified. So here also you can see the T-shape, L-shaped, counterfort, butters. These are the types of retaining walls, and depending upon the backfill of the soil conditions, which will be feasible and what is the load coming over that walls, how it is going to resist, that has been studied here. Then the force stability checking of the retaining wall is being studied. How you find the active pressure, how you find the passive pressure, what are the horizontal pressures, what is the overturning movement, if it slides, what is the alternative for that, what precaution should be taken. So all this stability checking will be done on retaining wall. Once the dimensions has been given to the retaining walls, we check it for the stability. Once the stability is okay, then we go for designing of the component of retaining walls. Today's class we start with the design of retaining wall. One example is taken, and from the given data we are going to design it. So as again for this we have following steps. The steps are not written here directly, I have taken the problem. The steps to be remembered to design a retaining wall is, first write down the given data. Then for given data, check the stability of the retaining wall. Once we find it is safe against the stability, then we start the designing the component wise, that is stem, hill slab, toe slab. Then we are going to provide the reinforcement. Depending upon the maximum bending moment, the depth has been checked. Then we are going to give the reinforcement, provide reinforcement with that for moment. Then we are going to check it for shear. This is what we are going to do here. So steps are the same here as I told. Write the given data, calculate the proportionate of the retaining wall, then check for stability. Once it is safe, go for the further designing of the components. If it is unsafe against stability, redistribute the dimensions of the retaining wall. Then once again check the stability. Once it is safe, then move forward to design the component separately, that is stem, heel and toe. So by now taking one example, you will come to know exactly what should be done here. So let us consider retaining wall here. So one example is taken. Design a cantilever retaining wall T-shape to retain earth for a height of 4 meters. The backfill is horizontal. The density of soil, that is density of soil is given as 18 kilonewton per meter square. The SBC of soil given is 200 kilonewton per meter square. The coefficient of friction between the concrete and soil is 0.6, that is mu value. Then the angle of repose is 30 degree, that is a friction of soil between concrete and soil, that is 30 degree. Here we are going to use M20 grade concrete and Fe415 steel. This is a given data. Here you need to design the T-shaped retaining walls. The backfill given is 4 meters. So first write down the given data. So given data are SBC given as 200 kilonewton per meter square. The height of backfill 4 meters. Density of soil as 18 kilonewton per meter cube. The coefficient of friction between soil and the concrete and the soil is 0.6. The angle of repose is 30 degree. That is the friction between the soil particles. Pi value is given as 30 degree. We are using M20 grade concrete and Fe415 steel. So noted down the given data here. You can see the data is shown here. H dash, the backfill we call it as H dash, which is a 4 meters, and SBC given as 200. Density of soil 18, mu value 0.6, pi value 30 degree. So for this, what is the next step? That is to fix the height of retaining wall, we need to find the total height of retaining wall. That is the height of backfill they have given, but below that we go for foundation depth. So calculate the foundation depth. For that we have a formula here. To find the depth of foundation, we have a Rankins formula. That is depth of foundation equals to SBC by density bracket of 1 minus sin pi divided by 1 plus sin pi whole root square. That 1 minus sin pi plus 1 by 1 plus sin pi, that is nothing but a Ka, that is active earth pressure. Pi value is given as 30 here. Substitute the value of pi. We get K value is equal to 0.333, that is 1 by 3. SBC is given as 200. Density as 18. So substitute the value of all that. SBC 200 into 0.33 whole square divided by 18. We get the depth of foundation as 1.23 meters below ground level. So we are taking as 1.2 is the depth of foundation. So the total depth of retaining wall becomes H dash plus F df. That is H dash is 4 meter, df is 1.2 meters. So total depth of retaining wall is 5.2 meters. That we can see in the diagram here. Yes, we can see the diagram. The height was given 4 meter above ground level. So depth of foundation we found as 1.2 meters. So capital total H will be 5.2 meter from top of the ground to the foundation bed. We get height of retaining wall as H 5.2 meters. This is what we have found here. Next, finding the proportions for the walls, that is the size of the wall. How we are finding? We have certain formula given to find this. We can know that the thickness of base slab is assumed as 1 by 10th to 1 by 14th. H means the height divided by H by 10 to H by 14. In between that range, there should be the depth of your slab. That is depth of slab means this slab I am saying. This slab of this should be in between H by 10 and H by 14. H is 5.2. So H by is 5.2 means 5.2 divided by 10 we get 0.52, and 5 by 2 divided by 14 we get 0.43. So in between this the thickness should be there. So we are assuming 450 as a thickness which relies in between this. Next comes is the width of base slab. Width is nothing but a B. We can see in diagram this is B here, width of retaining wall. B we are taking base, that is B is equal to 0.5 to 0.6 times H, that H is 5.2. So 5.2 into 0.5 we get 2.6 meters. 5.2 into 0.6 we get 3.2 meters. So your width of foundation should be, base slab should be well within this range. So we are taking 3 meter as a width of base slab. Next comes the projection of toe here. You can see base we have given 3000, depth we got it as 450. So stem is there, heel is there, toe is there. This part we call it as a toe, this part we call it as a heel, and this is a stem. can write it like this. For still more clearance, this part, and this part. I can write it so that this is here. This part we call it as a toe, and this part we call it as a stem. So the width of base slab we got 3000, the thickness we got it as a 450. So I want to know this width, how you get this. So the projection of toe beyond the stem will be in this fashion with the formula given: 1/3 to 1/4 of h. H is 5.2. 5.2 divided by 3 we get is 1 meter. 5.2 divided by 4 we get 0.75. So this is a range where we were giving the projection of toe. So I am assuming 0.75 meter as the projection of toe. And the thickness of stem is given, assumed as 450 at the bottom of stem and 200 at the top of the stem. So which is 450 and 200? See, this we call it as a stem here, entire stem. It is depth provided here. We are assuming thickness of stem at top as 200. At the bottom we are taking it as a 450 because the pressure will be from this side. So here the maximum movement will be there. So this thickness should be more than the top. So top is 400, 200 and bottom is 450. The soil retaining side will have a vertical side of this stem. The other side, on road side or exposed face, will have a tapering end. You can see from 200 to 450 it is joining the taper. This side it is vertical. So this should be kept in mind. So we have given the dimensions here. So we are providing 450 as the thickness of stem at top, bottom and 200 at top. Definitely the size, the length of heel slab will be total 3000 divided by minus of 750 minus of 450, left with 1800. So this is how we fix the dimensions of the profession of walls, that is retaining walls. Now before going to design these individual component, let us first check the stability of this one. So stability, we came to know that this is a diagram we can see whose stability should be found. So here the height, here h is given, h dash is. You can see the stem is divided into two here. One is a rectangular one, W1, and tapering section towards the end will be W2 value. W3 is the thickness of entire slab. W4 is the backfill, which is above the heel slab. So that acts in downward directions. Beyond this, the soil pressure will have horizontal forces. So W1, W2, W3, W2. W1 is stem with the rectangle section. W2 stem with the tapering section. W3 the slab section, bottom slab. W4 the backfill above the heel slab. Then comes the horizontal pressure P due to the height. You can see calculated the P value. And below he has shown the uplift pressure provided at the joint T and enter T. So given is this one. So we need to find the stability here. Stability means there are at least 3 steps to be found. First, the structure should be safe against a overturn, that is mr divided by m0. M0 is the overturning moment which is due to the horizontal pressure. Mr is a resisting moment which we found due to the vertical force acting downwards. So mr divided by m0 should be greater than 1.55. That is the one safe against overturning. Next comes safe against sliding. So sliding means again the horizontal force PA will be there, active pressure acting in horizontal direction. This pushes the member. So it depends upon the stability of the structure. That is weight of structure W, then multiplied by friction of coefficient friction of soil and concrete divided by the horizontal force. If this is greater than 1.55, yes, it is safe against sliding. In case if this is not safe against the sliding, it is unsafe, it's less than 1.55, we need to provide the shear key, which acts as a key at the bottom of slab, which is straight to the stem itself. Once you give the shear key, it will be safe, then we provide the shear reinforcement. So this is what we have learned here. Next, the third step, finding the uplift pressure. So when we find uplift for the whole span, make sure that this uplift pressure should be available within the SPC of given soil. Once it is there, then safe, then go with the professional design of the component individually. If the uplift pressure is more than SPC, redesign the structures, change the size of structure and do it. So let us know what is the stability should be done here. So for stability, we can see the diagram here, a cantilever slab, vertical slab, slant slab, backfill. So W1, W2, W3, W4. We are taking movement of all these components towards the end of toe here. So how it acts, movement you can see here. We have made a table for this, that is load, force, distance with the toe end, movement will be at toe point. So stem at W1 will be, the height of stem is, we know that 5.2 is the total height of the structures. In that, the thickness of soil we have given as 0.45, so the height of stem becomes 4.75 here. Instead of 5.2, it will be 4.75. So for the stem, rectangular section W1 equals to 0.2 thickness at top into 0.2 into 4.75, the height of stem into 1 per meter width into density of concrete, that is 25. We get the magnitude of stem W1 will be 23.75, and the lever arm, that is distance of this stem center point to the toe point, 0.75 is the toe end. You can see we want to know CG from this end to this end. From this end to this. So when we take a rectangular section, so 450, 200, it is 450, so left with the 250 here. So 750 plus 250, it will be almost 1 meter, plus half of this 200 will be 0.1, so 1.1 meter from toe end, that is nothing but a lever arm. We can see here 1.1 lever arm. So multiply lever arm with your magnitude, we get the moment as 26.13 kilonewton meter. This is due to rectangular section of stem. Similarly, the section, second one, the triangle section. So this is in term of area here. The triangle means top it is 0, bottom it is 250. So find the area of triangle into density of concrete. That is half, width is 250, height is 4.75. Material required by the density into per 1 meter width. We get the stem which is in inclined section will have a magnitude of 14.84. Then lever of this with respect to the T value, that is 0.75. This will be, this side it will be 2/3 of the section. So 2/3 of 0.25, you can see 2/3 of 0.25 plus of 0.75 will give the width, that is 2/3 means 2 into 2.5 is 0.5, 0.5 divided by 3, this will be not 3, it is 916. So 14.84 into 0.916, we get 13.6 as a moment. Then area of slab, that is 0.45 is the thickness of slab, bottom slab, length is 3 meter into density of concrete, then per meter width we get 3 into 4.5 into 1 into 25, we get 33.75. This into half, that is 3 divided by 2, 1.5. This into this, we get a moment of 50.63 kilonewtons. Similarly, the backfill, we can see the backfill is there. So how we find the CG? I can say one thing. The CG of rectangular section will be from this end to this end. This is one section. Let us show it. is individually so that it will be easy for you people. This is from CG. I am taking randomly. Then CG of this triangle with respect to this T, that will be there. So you can see here, I am taking random here. So when we take a base lab, the base lab will be at the mid span like this. So midpoint with this will be 1.5. Then for this rectangle sequence, CG will be at this point. So these two section, we get it in this fashion. This is what the CG area of this individual one and CG we can see. So the same term backfill, that is 1.8 meter, heel width, height of backfill 4.75, density of soil. Make sure that when you calculate the first three W1, W2, W3 are concrete one, then the backfill is from soil. So you take density of soil and don't make mistake by taking density of concrete here. So backfill is soil. You can see the backfill is taken like 18. So the total magnitude of this backfill will be 1.8 into 4.75 into 18, that is 153.9. Then the distance from A, that is lever arm, W4 will be L4. L4 is nothing but 0.75 plus 0.45, 0.75 plus 0.45, then half of 1.8, that will be 0.9. Otherwise, total 3 meter minus 0.9, we get 2.1 meter as a lever arm. Multiply this with 153, we get a moment of 323. So add all the total vertical movements, that is 226 meters. Add all the movement which is rotating vectors, that is moment of resistance will be 413. So these all loads are downward. Then we have some horizontal pressure acting in horizontal directions, that is pH. So pH is equal to Ka density into height. You can see this. This will be, you can see this is a horizontal pressure acting in this fashion. So you can see like this, the horizontal pressure will be there. Total height, this value we call it as a Ka density into H. H is this, density is the soil of this, then Ka is active earth pressure in horizontal direction towards the left hand side. So that formula is applied here. Ka density of soil into height. This is not 5.22, it is 5.2 square, I think. You can make it as a square here. How? So W, this is Ka into W into H square by 2, that we got 81 as a horizontal pressure, into density into the lever arm H by 3, that is 5.2 divided by 3. We get a moment at horizontal position as m naught 1 naught 40, that is a reversing moment. This is the moment will be in this fashion, anti-clockwise. This all will act as clockwise like this. This is the only moment acting like this. This is only movement acting like this anti-clockwise. That is, this will act like this anti-clockwise towards this, and this all will act as clockwise. That's what it is called resisting movement. This is overturning movement. This is resisting movement. So because we can see here, this is a resisting movement which is coming downward, which is horizontal. That will be the overturning movement. So actually, let's check for the density here. Check for overturning. That is summation of moment of resistance divided by summation of overturning moment. We got 413 divided by 140. We get it as 240. That is 413 divided by 140. We get answer as 2.94. That is greater than 1.55. Hence, it is safe against overturning. Similarly, second one, sliding. Check for sliding. Second one, that is FOS, factor of sliding. We can see mu into summation of vertical downward force divided by horizontal force. We can write this also as like this. So 0.6 is the mu value multiplied by vertical downward force. That is, you can see 226.24. That is 226.24 divided by horizontal pressure. That is 81.04. So this is what we have got pH value. So if you substitute this, to calculate this value, we get it as 2.94. Sorry, this will be not 2.5. Go guys, we can calculate it. We can take a calculator and do it. Let us take calculator. Do this. That is 0.6 multiplied by 226.24 divided by 81.04. It is 1.67. So this will be 1.67, which is greater than 1.55. Again, it is safe against. You can see it is safe against sliding. Next comes substance, means it is nothing but a uplift pressure. So what is uplift pressure is a, for this we have formula. Pmax is equal to summation of vertical force divided by width of retaining wall, bracket of 1 plus 6E by B. This is what I think you have known, this maximum pressure. If it is plus, it will be maximum pressure. If it is negative, it will be minimum pressure. So you know the value of D. D is 3 meters we have given. Summation of W is 226. What about E? E value you need to find here. So to find E value, E's value you can see here. It is nothing but a V by 2 minus of X. What is this X? X is nothing but, you can see here, X is equal to summation of moment divided by summation of vertical force. Summation of moment means adding these two. This is 413 minus 140. That will give the summation of moment divided by summation of vertical force, that is 226. We do this, we get this X value as 1.2. And according to our rules, this should be less than B by 3. B is 3 meters. So B by 3 means over 3 meter by 3 we get 1 meters. So 1 point is greater than 1, then it is safe. X value is safe here. Once we take X value as 1.2 meter, E value, substitute X is equal to 1 here, 1.2 here. So 3 by 2 minus 1.2, we get 0.3, and this should be less than B by 6. What is B by 6 here? B is 3 meters, 3 by 6, 3000 by 6, what we get? 500 we get. 3 means 500, so 750. 750 means 0.75. It is less than 0.3 is less than this, so it is safe. E value is safe. Now substitute the value of E in this. That is summation of this one equals to summation of W means 226 divided by 3 bracket of 1 plus 6 into 0.3 divided by 6 bracket close. So maximum pressure, when we take this as a plus, we get 120 kilonewton 0.66, which is less than SPC. SPC is taken as 200 here given. Next, the minimum pressure will be 226 divided by 3 1 minus of 6 into 0.3 divided by 6. We get 30 kilonewtons meter square as a minimum pressure at the heel end, which is also greater than 0. Hence, it is safe. So we can say the both maximum pressure as well as minimum pressure are safe here. So is it clear, guys? Stability analysis is clear? Hmm? I'm asking you people only. Jayasri. Jayasri, are you there or not?
Yes, sir.
Is it clear how the stability should be found? Hmm?
Sir.
Okay. Any other body having any problems? Any in understanding the stability? Because once the stability is safe, we can go for the design of further one. Otherwise, we should redesign it. Here we got the safe design, so we can continue it. So I'm asking whether you need to continue or you need to stop here only. Hmm? Students, I'm asking you only whether I need to continue the class or I should stop here only. Divya. Ashwini,
Yes, sir.
whether I should stop here only or I should continue the class. What to be done? Hmm? ಹೇಳ್ರಿ ಕ್ಲಾಸ್ ಕಂಟಿನ್ಯೂ ಮಾಡು ಇಲ್ಲೇ ಡ್ರಾಪ್ ಮಾಡು. What to be done? You have checked for stability. So you can see the diagram here, how it is given. H, this is DF. These are W1, W2, W3, W4 work forces. E value is given here. This is a resultant force. E value is given. It is B by 6. This is B by 2. This is X value. Total is B here. How we found the uplift pressure? So uplift pressure as per diagram, I have got 30 kilonewtons at heel point and 120 kilonewton at toe point. Just below the toe stem here, I have got calculated the forces at this and this point. That we can do by similar triangles and find the forces at this and this point. This is what we have done. So I think today I will stop it here only. So design of a stem, design of heel slab, I will continue in the next class. Today's class we will stop at only stability only. Clear? Hmm? Students, is it clear?